Welcome to another structure analysis video from Ultralight Airplane Workshop. So this is part 3 of a series that I'm doing for the Truss style nose rib for the UWS-4 ultralight airplane. And when I say ultralight airplane, I mean an airplane that meets the Part 103 regulations here in the United States. Now in the last video, we made a template for cutting out the aluminum for the rib. So it has a shape like this, and the result is a piece of aluminum like this. Now I'm using 16 thousandths aluminum. Now I'm doing that because when I did the last series on the cantilever style rib, 16 thousandths worked pretty well. So that's what we're going to go with again here for the truss style. But now that we have our aluminum cut out, we need a form to form the aluminum over. So what's going to happen is these little flanges along here will be folded over, leaving about a 1/2 inch wide web here. Same thing here. There's going to be a 1/2 inch here that's folded over, 1/2 inch here that's folded over. And on the inside, it's going to be folded over, and on the outside, there's going to be a 1/2 inch flange that will put rivets through the skin into the rib for the airfoil shape. So we need to go ahead and make that form. In the last video, I had already cut out the outside, but I had not cut the inside out yet. So we're going to use the same method we did on this template. We're going to use our router to cut out these inside edges. These edges are all straight in here, except for this one right here. So it'll be easy to do with the router. But unfortunately, that's going to leave me with 1/2 inch wide areas along here. The form is going to be very narrow, and it's made out of plywood, so it's not really going to be that strong. So I need to glue this down to a backer board that will help keep it rigid, but can also carry the load when we're going to do the hydroforming. So let's get that going. Actually, no, that's not where I want it. Now, an example I saw of doing hydroforming using rubber, they use an inner tube to put down as the first layer. I don't want to go out and buy an inner tube. I don't have any scrap inner tubes laying around. So I bought a 1/16 inch thick piece of rubber that I'm going to use as the first layer. This will be sacrificial. Since it's fairly cheap, it's easy to buy another one or find an inner tube eventually and use. So that will go down first. Now, keep in mind, this is an experiment. I don't know how well this is going to turn out. I didn't want to spend a whole bunch of money on rubber and decide I didn't like it and it wasn't going to work very well for me. So I only got 12 by 12 inch pieces. Now it's not going to cover my entire rib at one time, so I'm going to have to do it in sections. I also have a piece that's diameter 30. That's this one here. This one's the 30. So it will go down next, and then I'm going to put the 50 down. Now I don't know if this is going to be too stiff, too soft. I have no idea what's going to happen. I'm just going to have to experiment with it. And then I've got a piece of wood block I'm going to put on top that will help distribute the load. And then I'm going to use a hydraulic press that's got a pretty much a point load. It's a 1-inch shaft that comes down, so I'm going to use this steel to help distribute that little 1-inch load out a little bit farther. Now I can't do the full press in one section and then move to another section to do a full press all the way down. The problem with that is that here on an edge where it would press down all the way, but it would be up here, it will stretch a lot in this one section. And I don't want that, because that stretch out, then I'm going to have to go back and recrimp it to take the stretch back out. So what I'm going to do instead is I'm going to do little sections at a time, probably 3 sections at a time, and I'll do a little bit, move to a section, do a little bit, move to a third section, move it a little bit, go back to the original section, move it down a little bit more, and then keep moving around like you would do if you were forming with a mallet. And pardon me for the furnace noise. It's minus 6 degrees here now, and so the furnace is running a lot. I've been trying to record in between times that's running, but it's running a whole bunch, so let's just ignore that for now. So I have a 12-ton hydraulic press over here that I'm going to use to do the pressing. I don't know if it's going to be enough pressure to do it. That's something we're just going to have to find out. Well, I think it's enough stalling here. Let's get to it. Oh, man. Ooh. that time. Well, that went better than I thought it would. Let's first talk about some things that aren't quite right. I would not use this rib in an airplane, at least not an airplane that I'm going to fly in, because it has a couple of issues. It may not have come across in the video, but once when I was screwing the index screw in, the screwdriver came off the head of the screw and then impacted the aluminum right here. And there's a divot there, which is a great place for a crack to start. So that's pretty undesirable. The other thing is I need to use something different for these index screws where I'm screwing them in. I need to use something that isn't going to cause quite a dimple in there, because that's, I think, too much. And that's probably a good place for a crack to start also. So that's not good. I will change that. So another thing is flutes. Now, where I put some initial flutes, like here, let's see, here, and here, you can see in between there, it started some of its own flutes when it was trying to, well, it wants to shrink this down, but it can't. And we have it actually an outer bend here, which is not as good. So there were some issues there. This one also didn't quite go. It's actually bending out here where I had a flute. So I'm going to have to work a little bit more on that, understand that a little bit better. I have a place here also where I've got a crinkle, a bend that I did not expect to have. And this one's starting one also. I think what I'm going to have to do is something like I did back here on these corners, is have a little bit of a fish mouth cut in here, and probably a couple more in here. If I had not bent this down, had not sanded an edge in here, then this would be flat and that wouldn't be an issue. What I wanted to do is have a little bit of stiffness out here, since there's going to be a fair amount of stress right in here. If you remember on the cantilever rib, it failed right in here, it buckled. So when I start putting a load on here, the same thing could happen. So I was wanting to stiffen this up a little bit, but it just may not work. I may just have to do some fish mouths in here to relieve some of this bending. Well, we'll find out in testing if this is a failure point. It's already kind of weak, we'll find out. Oh, back to these flutes. I'm going to, by hand, go ahead and finish fluting these out. You may be able to see that it isn't quite a 90-degree bend in here. It's about a 65-degree bend probably instead of a 90. So I'm going to go ahead and finish this up by hand. And also in here, it's not quite a 90, but by golly, in here, it actually did pretty good. It's almost usable as is. But I'll put a little bit more and go ahead and make it a 90. Now let's talk about things that actually worked out well. Well, what we were just talking about, going to these 90s, it almost went to a 90 in here. So that is great. One of the things I did is I measured the pressure on the pump. I have a little pressure gauge on my hydraulic jack there. And after I got done, I went and checked. It's a 12-ton hydraulic jack, at least it says it is. I put 5 tons of pressure on it instead of 12 tons. Now, I sanded some small curvature in here on these inside corners because, again, I wanted to stiffen these up a little bit, because this is going to be one of the weak spots if it isn't a little bit stiffer. In compression, I'll probably have a failure up in one of these corners. So I put a little curvature in there to try to get at least a little bit of a flange, and that worked. At first I didn't think it was going to do it, because as I was putting the initial bends in, there was almost nothing going on in these corners, but it eventually did, so that was great. Now I do need to make 2 of these, because I'm going to test in the positive load direction, so load pulling up this way, and I'll make a test in the negative load direction, which is pulling up this way. So I'll have one rib for each of those directions. So when I make the second one, using the same method, so pressing a little bit of it down at a time because I haven't ordered the much larger pieces of rubber yet, I'll make some corrections. So I'll go ahead and put some notches in here to try to get rid of some of the issues that I'm having with little crimples occurring in here. I'll fix these corners just a little bit better here. And I'll double flute in between rivets up here where I have more curvature to get rid of some of the problem with it making its own flutes up in here. And while I've got this one here, this pledge, even after it's dried, there's a little bit of lubrication, which I'm very pleased. So even when it's dried, it's lubricating a little bit. Now, I didn't really have as much lubrication as I probably should have because I was doing a little bit at a time. I'd press down a little bit, come over to another section, press down about the same amount, go to a third section, press down about the same amount, and then when I got back to the original section, now I'd press down more. So I pressed down going around. And so once I did the first press, I imagine most of that pledge was wiped off and I didn't have much lubrication for second, third, and fourth rounds coming around. So when I finally built a larger press, and what I'm thinking of right now is a press that's 36 inches wide and 24 inches long. That'll let me do larger ribs, in fact the main rib, because the main rib's about 26 inches long. It'll let me do most of the bulkheads on the fuselage. It'll let me do all the other ribs and bulkheads on the airplane. In fact, I can probably do multiple ribs. For example, aileron, flap, elevator, rudder, all those ribs. I could probably do a bunch of them all at the same time. Of course, I have to make quite a few forms to do that. And speaking of forms, this form turned out pretty well. It didn't break away from the baseboard, so I'm pretty happy about that. So it actually worked out. I was a little bit worried about the glue bond breaking, but that part worked. So as long as you're pressing straight down on it, I think this kind of form works pretty good. Now I did have some issues that I haven't talked about yet. And that is that I neglected to deburr these inner edges here on the templates. And so that, I believe, caused me a problem. Because on this waist part that I have, I've got some holes. I got about 5 little fish mouth type holes. And that occurs right here on these little curves here on the aluminum. Now it's possible it wasn't just deburring that was the issue. It could be that this is such a tight corner that this just pulled apart. But I don't think so. I think it was cut more than anything. So I got to do a better job of deburring these edges. And I think this was a great idea, having this throwaway piece of rubber. So I'm going to buy more of this. Let's also talk a little bit more about rubber. Now what I used initially was a 50 durometer and a 30 durometer. So the 30 went down on the aluminum and then the 50 was on top of it. I didn't know what hardness I really needed here in my rubber. So I figured if the 30 seemed to flow too much and wasn't putting enough pressure on it, I was going to flop around where the 50 went below and the 30 on top. But I think the 30 is about right. So when I make the bigger one, I think I'm just going to make 2 layers of 1 inch 30 durometer rubber. And another thing when I make the bigger one, this rubber likes to flow a little bit when you start getting quite a bit of pressure on it. Now one of the things I noticed is over here on the edge, when I was pushing down on it, this rubber was bulging out, which I think means that I was losing pressure out here on the edge. So instead of pressing down, it was moving out. So when I make my new press, I got to make sure that there's a dam up along the edge to keep that from going out so I get better pressure straight down. Another thing, I'm going to try some different fluting pliers. I really don't like these, so I'm going to try another brand and see if I like them a little bit better. And then in the next video, we're going to do some testing. Now in that video, I plan to build a whipple tree. In the previous video where I did weight testing on the cantilever style nose rib, I had a whole bunch of rebar that I hung. I think instead of doing that, I'm going to build a whipple tree that can put the right amount of load at each rivet, and I can have one hydraulic cylinder that pulls. And then I'll put a sensor on it so I know how much it's pulling. So I'll talk about how I calculated all the loads for the whipple tree, how it all goes together. That'll be a lot of fun. And I think in the same video is when we'll do our load testing. And so I'll do that testing similar to the way I did it for the cantilever rib, where I want it to be semi-realistic, where it's in a wing piece. So I'll basically be reusing this, where I have a spar with spar caps, spar web, and a skin. And I'll stick the rib inside, and I'll rivet some fixtures on here so I can attach the whipple tree and put a load on it. Okay guys, well that's it for this video. Thanks for watching. Until next time.